part of section 2 here deals with radians, some definitions here, arc length, and this thing called a unit circle. So let's start off. A radian is going to be a measure of an angle. So there's degrees and now there's radians. Our angle will be called theta. That will be the symbol for it. It's got to be in standard position. Terminal side that intersects an arc with the same length as the radius of the circle. So we'll talk a little bit more of this. This is going to lead to future things to do. So here's our diagram. And I've done everything counterclockwise, so 90, 180, 270, 360. It started at 0, so that would also be 360 as well. So here's theta. The radian is the measure of the angle, theta, in standard position. Terminal side has to intercept an arc with the same length as the radius of the circle. So this arc crossing has to be the same length as the radius of the circle, I guess, if I take this all the way out here to there. Okay, so there's our definition, and bear with me. Let's say, for instance, that we're dealing with this, and R is equal to 1. So here's R equal to 1. If R were equal to 1, we plug it in here, circumference, C equals 2 pi R. And if R was equal to 1, our circumference would equal 2 pi. So my circle here, so the circumference, that's what? The distance all the way around. So I start here and come all the way up at 360 would be the equivalent of 2 pi. Will be the equivalent of 2 pi. Something to keep in mind. So if that would be the equivalent of 2 pi, if I only went to here, halfway around, what would 180 degrees be equivalent to in terms of our circumference? Those of you that said pi are correct. Very good. Okay. We're going to come back and fill in a thing or two here. Let's go back down here. We've got a couple formulas. So the degree and radian relationship. If I want to go from degrees to radians, it is, now by the way, that would be the measurement in radians, 2 pi. Measurement in radians, so kind of like circumferences. When I see pi involved quite often, I'm dealing with radians. So if I had a degree, I took it times pi over 180, I would get how much would be in radians. So let's look at this for a second. If we took 360 times pi over 180, reduce, well, what do you know? 2 pi, and I set you up to figure it out. So my question to you then is, what would a 90-degree angle be? Now you can look at it here and do this. I'm going to set my formula up and do over 180, knowing that'll cancel. So pi over 2 is typically how you see it. Some people will say 1/2 pi. So this will be pi over 2. So the next question I have for you is, what's 270 going to be? Well, let's see. I can plug it in, or I can look here. So 3 pi over 2 is equivalent to 270 degrees. Next, if I got radians, how do I go to degrees? How do I know I got radians? I got pi involved. I multiply by 180 over pi, notice. So let's say I had pi over 4 radians. I take that times 180 over pi. Those will cancel out. 4 goes into 180 45 times. So that's a 45 degree angle. Pi over 4, 45 degrees. All right, central angle. You should remember this from geometry, at least I hope. Very simple. Your vertex is going to be at the center of the circle. So here I have a central angle. I'm going clockwise with my orientation right now. Initial side, terminal side, there's R. If you recall back in the days of geometry, you had 2 pi r times m over 360. That would tell you arc length. That right there. Telling you now, with our circles, we can do this. We can take r times theta, and we will get our arc length. S is arc length for whatever reason. So the arc length formula, S equals r times theta. So let's look what we got. I got a circle that has a 9 centimeter diameter and a 60-degree center angle. Find the arc length. Okay. Well, if I was back in my good old days of geometry, I would go 2 times pi. This is a diameter. I need a radius, so 4.5 times 60 over 360. What fraction of the circle we're taking out? All right, so this is 9 pi times 1/6 when you reduce, and that's going to give us 3 pi over 2. That's in radians. All right, we need to know the arc length. Okay, arc length, what would that be? So in other words, how far around is that going to go? So then I would have to convert this to get pi out of there. 180 over pi, cancel out there, equals 270 centimeters. Yes, I think some of you found a direct relationship there in this example. Or, my friends, we could do something like this. S equals R times theta. R, 4.5. Theta, 60. You be the judge on that one. So, no other information. Goes a little bit quicker. Okay, the final part here that we want to deal with is the unit circle. And I will have, there will be uploaded a PDF of this so you can download it and use it to help you out as you're doing these problems, but it's always good to have this thing handed around. I want to fill in a few things. And then the rest of the thing is for you to fill in without going and looking on the internet for this. Try what you have learned or what you have taken in notes to fill out what we have. Okay, now, first and foremost, the unit circle is based on a circle that has a radius of 1 unit. Radius of 1 unit. So as I fill this out, because I'm going to give you some of it, you've already calculated some of it in some of the examples. That means from vertex all the way out to here is 1 unit. So what ordered pair would I be here at this point, knowing that I'm at 1 unit? For those of you that have said 1, 0, you're exactly right. So from my vertex up to this point, we would be at 0, 1. Vertex to this point, -1, 0. Remember, x values go first, my friends. And then from vertex to this point would be 0, -1. Our unit circle has a radius of 1. Radius of 1 for the unit circle. Okay, so now you can see there's a couple things labeled in here. For instance, degrees. So let's go in a counterclockwise position as we do this. So degrees, I would be right here. If my terminal side was here, 0 degrees. I'm all the way up to here. You know this to be 90 degrees. All the way over to here. Yes, I can hear you all saying it now. This would be 180 degrees. And again, we're going in a clockwise manner. This would be what? Right, 270 degrees, and then a full rotation back to 360 degrees. Very good, very good. All right, now let's use some radians because we have been dealing with radians. So if I'm at, and again, what's in with radians? Right, pi. You learned from earlier, going back to this, that a full rotation, 360 degrees, is equivalent to 2 pi. Using logic, we decided that a half of a circle would be 1 pi. And through either logic or using our conversion formulas, we know that this would be pi over 2, and we know that this would be 3 pi over 2. Now there's one I haven't filled in, and that would be right here. Instead of going a full complete circle, where do we start? Well, 0 pi. So the challenge I have for you is to fill the completed unit circle out. You might have questions with it as you do it. Without looking, try to fill this out and see what you can come up with. My hint to you is this. Can I find distances? Can I do anything in terms of triangles to help me out? Sines, cosines, tangents. You've dealt with those. Right triangles can be involved. Along with that, when you do things in radians, make sure you're using fractions and pi, no decimals at all. And then your degrees will come out as they are. Good luck.